Here, today we are going to solve a typical sum where a triangle is inscribed in a circle. So it is like this. A triangle is inscribed in a circle. The radius of the circle is r and the two sides of the triangle. This is the length of this side and the length of two sides of the triangle is given and the included angle is given. We have to prove that m into n is equal to 2r into h. So the question is like this, just see this. A triangle is inscribed in a circle of radius r. The height of the triangle is h and two of its sides are of length m and n with an included angle theta. You have to prove m into n is equal to 2rh. So let us write that. So let us name the figure and I write the question once more. Question. Triangle ABC is inscribed in a circle of radius r. The sides of the triangle are m and n with the included angle theta. The height of the triangle is h. To prove that m into n is equal to rh. The figure is like this. So I have named the figure 2r ABC. So it's the triangle ABC which is inscribed in a circle of radius r. O is the center of the circle. Height of the triangle is h. And two of the adjacent sides are m and n with the included angle theta. Now, before we proceed, I want to introduce you to a formula wherein using this two information given how to find the area of the triangle. So now we are using finding a formula to find the area of the triangle. So let us see how it is. Area of a triangle. This is the triangle type. Say this side is 10 centimeter, this is 18 centimeter, this is a perpendicular, so this is 90 degrees, and let this be 5. So when you have a triangle of this nature, you know the formula which we have learned in lower classes. Area is equal to half base into height. So half base is 18 and height is 5. Let's put the values here. Half into 18 into 5, 2 into 9 is 18. So 9 5 is 45. It is 45 centimeter square. So this is the area of the triangle. Now similarly, now I introduce you to another type. See this. This is the triangle. Now in this, the side is given. This is 10 and here another side is given. This is 18 and the height is not given in this. The angle between the two sides is given. So now if you want to find the area of this triangle, you need to find the height of the triangle. So let us draw the height here. This is the height. When you say height, this should be perpendicular. So this is at 90 degrees here. And let this height be h. Okay. So now we need to find the height of this triangle. To find the height of the triangle, but the angle is given 30 degrees. So with respect to this angle, this is the opposite side and this will be the hypotenuse. Okay, so let us name this say side A. Let us name this as side B. Okay, now let us take the sine of this angle. Sine of angle 30 degrees is h opposite upon hypotenuse, h upon 10. Take 10 this side, so you'll get h is equal to 10 sine 30. Now let us use the same formula. Area is equal to half base into height. So base you know b is 18 and h is this. So let us substitute here half into 18 into 10 into sine 30. Again 2 nines are and sine 30 is 1 by 2. So 1 by 2 into 18 into 10 into 1 by 2. Okay, 2 5s are and 2 nines are 9 5s are 45. 45 centimeters square. So we are getting the same height. But we have a different formula here. The formula, see, this is the sides which is including this angle. So the formula will be half into b into a into sine of a. That means the angle which is the two side which is containing the angle, that is the product of the two sides containing the angle and the sine of the angle. This is the formula which we are going to use to prove our problem. So if you put this in words, it will be like this. If length of two sides is given and the included angle is given, then the area of the triangle is half the product of the two sides containing the angle and the sine of the angle. So now we are going to use this particular formula to prove our problem and solve the problem. Let us see this. This is the figure. Okay. Now what is the formula for area of this triangle which we have just learned? So you have to prove what you have to prove here. M into n is equal to 2RH. So the formula which we have learned for finding is area of triangle is half into m into n into sine theta, because these are the included sides and the included angle is here. So this is the first equation. Okay. Now let us join B to, say this is O is the center of the circle. Let us join B to O. When you join B to O, you get an angle at the center which is called as a central angle. And if this is a central angle, this is the inscribed angle. And you know that a central angle is double the inscribed angle. So BOC must be 2 times BAC. So angle BOC is twice angle BAC. But why? Central angle is twice the inscribed angle. So let's put it. And what is the inscribed angle? BOC. BAC is equal to theta, which is given. So that means the central angle BOC must be equal to 2 theta. So this full angle should be 2 theta. So let us drop a perpendicular here. Let us name this as D. And this is a perpendicular, so this is 90. So let us name this as point D. Now if you see these two triangles, this and this are the radius of the same circle. This is perpendicular. This is 90. This is also 90. So by RHS rule, these two triangles are congruent. Because these two triangles are congruent, this angle should be equal to this. So this is theta. This should also be theta. And now suppose BC is of length A. If this whole length is A, this half of it should be A by 2. So this is A by 2. This should also be A by 2. Okay, because this is half, because the two triangles are congruent, D must be the midpoint. Or you can use other property, line perpendicular to the, drawn from the center of the circle perpendicular to the chord bisects the chord. So this is, both are equal to A by 2. So now that means this angle BOD, that is BOD is equal to angle COD is equal to theta. Both are equal to theta. Now let us take this particular triangle. This triangle. When you take this triangle, so in triangle COD, take the sine of this angle. Sine is this A by 2 upon R. So sine of theta is equal to A upon 2 into R. So A by 2R is a sine theta. Now let us let this be your second equation. Let's substitute this in this. Substitute the value of sine from 2 in 1. We get sine of area of triangle ABC is equal to half into m into n into a upon 2r. That is equal to half m n a upon 2r. Let this be your fourth equation. Third equation. Now, but area of triangle, we know it is as half base into height. That is a base we have taken as a and height is h. So half a into h. This is the fourth equation. This is also area of a triangle and this is also area of triangle, and the area is of the same triangle. So that means these two must be equal. So half AH is equal to half MNA upon 2R. Half cancel. A cancel. So H is equal to Mn upon 2R. Take 2R this side. You'll get Mn is equal to 2RH. Hope I am clear. I have explained it clearly. So this is the problem which we want to do.